In this video, we're going to experiment with how we can use comments in our Java code and how we can use data types to work with different types of data. So I'm already at my terminal, and what I'm going to do here is I'm going to actually work with a new file. Let's go ahead and write it here. We'll write nano, use the same nano text editor that we used in the last video, and we'll call this data types demo.java. And then go ahead and open this up. So we're going to start off learning a little bit about comments. The first thing we want to do is we'll go ahead and write a comment at the top of our file that's going to identify what this file does. So we're going to say this file will demonstrate different data types in Java. There we go. So what we do here is this / and asterisk. So the / is the one that's on the question mark key, and the asterisk is when you hit Shift 8. So / asterisk means it tells the Java compiler to ignore everything that happens between the / asterisk and asterisk /. So none of this is actually interpreted or read by the Java compiler. It ignores all of those things. So now we can say public class data types demo and open that with a curly brace, close that with another curly brace, and we'll go ahead and create public static void main string arguments, and we'll go ahead and end that method as well. So now in this method we could actually start writing our code. We're going to create a couple of comments here just to start off. So we're going to say Java has 8 primitive data types. Notice on this line I used 2 / and what this means is it tells Java to ignore everything from the / to the end of the line. So this isn't actually interpreted by Java as well. And if if we just want to see that this works, we'll go ahead and hit Control-O to save this file. We'll hit Control-X to exit, and then we'll compile this data types demo. Oh, need that Java extension, or else we're going to get this problem. There we go. Now, if we run it, Java data types demo doesn't actually do anything because we haven't told it to do anything yet. So let's go ahead back in. Oh, data types demo. There we go. All right. So Java has 8 primitive data types. There are a handful of data types here. We have probably the simplest is Boolean, and Boolean has 2 values. So when we declare a Boolean variable, we say Boolean my Boolean. We set that equal to true, or we can set it equal to false. And we can see what that looks like. The value of my Boolean is, and then we can go ahead and hit plus. That's going to add whatever the value of that variable is to our string. Now if we hit Control-O, and we'll go ahead and test this, we will just use our up key to cycle through our past commands, Java-C, and then we'll run Java data types demo. And you can see the value of my Boolean is false. So we can go back into our file, and you can see this is the first data type. Let's go ahead and say data type 1 Boolean has true or false as its value. It's basically just for identifying true or false, and we're going to use those more as we go through these lessons. The next one we can look at, data type 2, which is also pretty simple, but a little bit more simple or more complicated. It has more values. We'll use the byte data type. Byte has up to 256 values. It goes from -128 to +127. So byte can be declared just the same way. Byte B is equal to 100, or byte C is equal to, say, 127. And this is where we get into an interesting concept called overflow. So byte variables only have the values from -2 to the power of 7 all the way up to 2 to the power of 7 minus 1. So if we try to go beyond that, the reason for this is because we only have 256 values. Byte variables, they are represented by 8 bits. Byte variables are represented by 8 bits. And what that means is that we have 8 binary numbers, 1s or 0s, that represent this value. And using that, we only have the space to represent 256 different values. So byte variables can only go from -128 to 127. So now if we say system.out.println, the largest value of a byte is We'll go ahead and add C there. Now if we're going to run into a couple of interesting things here. One is we'll run into something we call overflow, which is if we add 1 to the largest value, something interesting is going to happen. So let's go ahead and set C equal to C plus 1. So we're going to run into another interesting problem here. We'll go ahead and see what happens when we try to compile it. 1 more than that is C. But this isn't going to work. When we type javac data types demo.java, you'll see here it's going to say it's going to lose values, and that's because Java picks up on the fact that we're adding to this. It wants this to be an integer, so we have to do something called casting. And casting just basically says, we know that there's a risk here, we know that this should be an integer, but we don't want it to be an integer. We're going to just say it's okay that this is still a byte. So this casting, using this byte keyword just to say we want to force this to be a byte, this is the result of this. So let's go ahead and compile again, and we will run data types demo. And you can see here, largest value of 127, or largest value of a byte is 127. If we add 1 more to that, it actually goes all the way back around in cycles. So that's something we call overflow. So let's go ahead down to the bottom of our file. We'll say this demonstrates the concept of overflow. All right, so now we have 2 data types. We've talked about bytes and we've talked about Booleans. Third data type here is short. It's 16 bits, so it has more space. Shorts aren't very widely used, but you can use them. Short S is equal to say 2000 system.out.println the value of our short variable. All right, now if we compile this and we run it, and the short value is what it is. Now the reason why we don't use shorts that often is because sometimes we'll use bytes when we're dealing with file input, or we're dealing with some kind of streaming input, because bytes represent what the computer uses pretty well. Shorts we don't use so much because we typically use int, data type for int. It's 32 bits, so it has even more space, about 2 billion. Negative or positive. A little bit more than that, but about that. So an integer, we can say int I is equal to, say, we'll make it a big number here, system.out.println the value of our int variable is I. And that will output that. And we actually have access to some special classes in Java. One of them is called integer, and each one of these primitive types, short or byte or Boolean or character, they all have all of this special class that we can use to identify things. So we'll say I is equal to integer.max value, and this will tell us how big an integer can be without overflow. Println the value of, let's get that typo out, of the biggest int variable is I. Notice we're just resetting the value of I here over and over again. Now if we compile and we run this, you'll see the value of the biggest, let's go ahead back here. The value of the biggest int variable is 2,147,483,647. So now we have a couple of things we're looking at. Let's go ahead and look at some more. We've now talked about 4 common data types. Now you might say, what happens if we need values that are bigger than 2, or approximately 2 billion? Well, we have another data type for that. Data type 5 is long, stands for long integer, or short for long integer. It's 64 bits, so it has even more space. You can go all the way up to 2 to the 63rd power minus 1, which is quite a lot. It's quite a large number, and we can see what the largest value of that is. We'll say long. Let's not use L, because L looks kind of like a 1. We'll say long variable is equal to long.max value, system.out.println the value of the biggest long variable is. Now if we want to see what that looks like, let's go ahead and compile here. Compile, then run. You can see that that's quite a big number. where we're getting into very large numbers now. And there are classes that we can use if we need to represent numbers even larger than that, but we typically won't have to do that in most programs. We also have two floating point types. So if we want to represent something like 3.2 or 0.0 or 0.000001 can be represented as a float. Data type 6, float. It's 32 bits and can represent normal decimal numbers. So if we say float f is equal to 0.000001, then we can say system.out.println, the value of our float is f. Now we can see what that looks like. Oh, let's go ahead and compile first. Compile. Oh, we forgot our semicolon. So you can see there we've got that nice error. Java just helps us out and lets us know. All right, we'll go page down. Here we go. Let's try again. Oh no, it doesn't like this. And that's because we have to talk about our next data type, which is double. So you won't see floats used that often because we typically use double. Data type 7, double. It's 64 bits, but it can represent normal decimal point numbers, but with greater precision. And the reason for it, so let's go ahead and cast this one so we can see that. Float. And down here we'll say double, my double is equal to double. Actually, we don't have to cast this one. 0.00000001. 01, there we go. And we won't have to cast this because it just assumes that we're going to use double here. The value of our double is double, or my double. Now if we go ahead and compile and run our program, now you see here this is going to tell us in scientific notation, so 1.0 times 10 to the negative 9th power, which gives us 0.0000000001, or the value of the double, which is the same. So we have one more data type that we need to look at, and that data type is data type 8 here. Last thing, data type 8 is char for character. Some people pronounce it char. I usually say character. I don't know why. I guess everybody has their own way to do this. It's 16 bits, but it can be used to represent letters. So I can use this. I can say capital A, system.out.println, the value of our character is, oh, we didn't give a variable name here. And we can't use C because we use C up above. So we'll call that first letter. Now the interesting thing about this is character is a number, but when we compile and run this, it's going to give us the value of A, and that's because Java is smart enough to know that when we're building strings out of characters, we want to use the character representation. But if we do something like this, we'll set first letter equal to first letter plus 1, system.out.println, the next character is, probably shouldn't have called it first letter because now that doesn't make any sense, but that's okay. Again, we're going to run into the problem of casting, so let's go ahead back into our file. Go ahead and cast this. Now that might seem like an annoyance now, but it will save you a lot of time in the future when you run into larger and larger programs. So you can see here the next character is B. Now an interesting thing that you can do, maybe it's not interesting, but it may be slightly odd, we could say int x is equal to first letter plus 10. Now you might think that this would show an integer plus a character is x. Now you might think that this would show the character, but what that's actually going to show is our number. So we'll see what the actual numeric value is here. Java data types demo. So you can see if we add 76 to B, we get, or if we add 10 to B, we get 76. And that's because when we're dealing with characters, each one has a numeric value. So if we say, we'll say car A, letter A is equal to A. We'll say int A is equal to integer letter A. We don't have to cast there, but we can explicitly do it. Now we can see what the value is. Print line, the character is the letter, or the integer value is int A. Now, if we haven't made any mistakes, we should be able to compile, and we run our program. You can see here that we have a character A, and we have the integer value is 65. So that covers all of the different primitive types. Java has 8 of them. We have a Boolean. We have a couple of numeric values. We have a couple of numeric integer values. We have a couple of numeric decimal point values, and then we have the character value. Now, strings through this whole thing are also sort of like a primitive in Java. We're able to use the plus sign to concatenate two strings together, to bring two strings together, or add other values to a string. So strings are objects in Java, but they work a little bit like primitives. We'll cover some more about strings in a future lesson. Thanks for watching, and don't forget to practice your coding.